Everyone, I am Jomina John, Assistant Professor, Department of Computer Science and Engineering, Rajuri School of Engineering and Technology. I am taking the subject CS208, Principles of Database Design. It is applicable to both computer science students as well as IT department students. Today I am going to deal with the topic B trees and B plus trees, which is in Module 5. Okay, Module 5, B trees and B plus trees. In the previous video lecture, I have introduced you why we are going for the tree concept in the database. So in the previous class, previous video lecture, I have told you a database is there. The database, we are creating indexing. So I have told you what is indexing. So from the indexing concept, we move to multi-level indexing. So that is multiple. First level, second level, like that indexing will be there. This indexing concept, I can make it into, that is just think. I am rotating, I can make it into a tree concept. So how we will make a tree concept, tree structure for the indexing of the database. That is what we will see in today's class. So for that one, we are mainly using B trees and B plus tree. Before starting with B and B plus tree, first I will introduce to you BST, that is binary search tree. All this concept I think you have already covered in the data structure concept. So how it can be used in the database for the indexing, that we will see in this current session. So starting with binary search tree is nothing but a tree which is having two children, that is that is known as binary. Say for example, this node is having a value 50. It will have two children. Normally it will be arranged like this. Lesser value I will put here. Greater value will be this side. Suppose I want to insert 30. That is 30 is less than 50. So I will come to this side. 30 is less than 40. So I will make here. Suppose I want to insert 45. So that is 45 is less than 50. I will come to this side. It is greater than 40. So I will put in this side. Likewise, we will be continuing. So that's why it is known as binary. By two children is the search tree. That is searching process I can do very efficient manner. Suppose I want to search for 45. 45 is less than 50. Move to left side. 45 is greater than 40. Move to right side. So likewise I can find the element. So this is the key value. So same way, it is only two children. I can extend this one to another concept that is known as M-way search tree. Search tree I have written it as ST. Search tree. M-way search tree. What exactly this M-way search tree is that? Suppose I am creating a tree like this. Say for example, it is having a value 20 and 50. I am creating a pointer to this one. Lesser values, that is say for example, 10 is less than that one. 15 is less than that one. So I am creating a pointer like this. This is having a value in between 20 and 50. Say for example 30 as well as 40. Greater than 50, that is say for example 60 as well as 70. So consider this tree. How many children is possible in this one? 3 children is possible. 3 children. How many keys are there in a particular node? 2 keys are there. So if 2 keys are there, from in between lesser, in between greater, 3 children may be possible. So that's why it is known as 3-way search tree. So 3 children, 3-way search tree. So in a 3-way search tree, how many keys will be there? 2 keys will be there. That means in an M-way search tree means M children will be possible, 3-way, 3 children. And M-1 keys will be possible. 3-way, 2 keys will be possible. Likewise. So that is about M-way search tree. Now, how to make a node like this? So in this one, say for example, binary search tree, if I am making a node like this, it will be 50. A pointer, child pointer from here, a child pointer from here will be also possible. That is how this tree is created. So in an M-way search tree, how can I create a node? Look at this one. That is 20 as well as 50. A child pointer from this one, another child pointer from this one, another child pointer. So this is how this node will exactly present in the system. Okay. Now, how can I make a node to become an index? Index means it should point to the data which is present in the database, right? So here, suppose I want to create a four-way search tree and I have to make it as a index, then I will create a node like this. Okay, so the node will be like this. Suppose this is key 1. Okay, this is its left pointer, this will be its right pointer. So this is child pointer 1, this is child pointer 2. Next, this is next key, this is child pointer 3. So next, this is next key, this is child pointer 4. So 4-way, 4 childs are there, 3 keys are there, that's okay. In between I have a space allotted. What is this actually? This is what is known as record pointer, which will point to that database record. So that is how a embedded search tree can be used as an index. So this will be another record pointer which will point to that database record. Clear? Next one, this will be another record pointer which will point to the record in the database. That is how MV search tree can be used as an index. Now, MV search tree, how we will perform the insertion operation, so that I have to move to B tree concept, we will see. Suppose I am considering some key values. So say for example, I am considering a 4-way search tree. Okay, the keys I have to insert is 10, 20, 30, 40 as well as 50. These are the keys I have to insert. Suppose I am going to create an MV search tree. Suppose 10 I have inserted here. From this one, suppose 20 I can insert here or here, right? Suppose I am inserting like this, 30 here, then 40 here, then 50 here, like this. This is ultimately a wastage of space. This is, suppose I want to search in this index, I have to search for 10, then 20, then 30, like that. A linear search I am performing. That means like entire database searching process itself I am doing here. So it is a wastage. There is no rule for inserting data, key values into an MV search tree. So I have to add some rules to this MV search tree, that a MV search tree plus some rules, we will call it as nothing but B trees. Okay, I will repeat, an MV search tree which is having no rules for insertion deletion of data, an MV search tree with some added rules, we will call it as B trees. Okay, so what are the rules in B trees? Okay, so first rule is, in a B tree, suppose it should have at least half of a node should be full in order to create a new node. That is, I am adding ceil value, that is m by 2 children must be there to create a new node. That is the very important first rule in B tree. That is, in MV search tree, I told you I am simply adding nodes. That's why it is not all useful one for the indexing. So B tree first rule is, in order to create a new node, there should be at least, it should be half full. Then only I can create another node. That is the first rule. Going to the second rule, the root. Okay, root node should have minimum 2 children. That is, whenever we are creating a root, it should have 2 children. How it happens? With an example, it will be clear. So the third rule is, so all the leaf nodes must be at same level. Okay, that is the third rule. So when we have a leaf nodes, it should be in the same level. Okay, that is what the third rule. And one more rule is there. We will, while creating the tree, we will follow the bottom up manner. That is the next one. So the bottom up manner we have to follow to create the tree in that one. So we will see with an example, we will see how to create a B tree in detail. Okay, so Suppose I am considering an example. Suppose m-way search tree, that is m size is 4, that is 4-way search tree, that is 4th-way binary tree I am creating. And suppose the key values are, say, for example, I am adding the key values like 10, 20, 30, 40 like this. So in a node, how many keys will be possible? 3 keys will be possible since it is m-way search tree. So suppose I am creating a node with like this. Suppose 10 I am inserting into a node. So 10 will be like this. In between there is child pointer as well as record pointer will be there. I am not going to detail about the pointers. So 10 is inserted. Next one is 20 I have to insert. 20 I am inserting here. 30 I have to insert. 30 I am inserting here. 40, whether I can insert 40 here? It is not possible since m is 4, m minus 1 keys. That is only 3 keys are possible in a node. Right? So 3 is there. So next I have to insert 40. So for that one, what I will be doing here, already created tree, I will split. So second step, when I am inserting 40, what I will be doing is, I will split into 2. That is, one node is here, another node is here. I am splitting. I can insert 10 here, 20 here, 30 as well as 40 is there. So 40 I will insert here. I will create a root node with 30. So this is less than this one, so child pointer will point to this one. This is greater than, so I will point to this one. Okay, one doubt may be there. Why? I can create 20 and 30, 40 here, right? That is also correct. So that's why two types is possible, left biased as well as right biased. That is, left biased means in left side more number of keys will be present. Right biased means in right node more number of keys will be present. So I am following here left biased one. You can follow right biased also. That is also correct. No problem with that one. So I have inserted 40 also. Suppose I am going to insert 60 as well as 70 I am going to insert. So 60, there is free space. I am inserting 60 here. Suppose I want to insert 70. 70 is also possible. It is, I can insert there itself. Suppose I am going to insert 80 there. 80 I am going to insert there. There is no space for 80. Right? 3 already insert. So what I will be doing? I will split it again. So what I will do? This side is same 10 as well as 20. This side is, what I am doing is I am splitting it into 2. That is 40 as well as 60 here. I have to insert 80. So what I will be doing? 80 I can add here. 70 I will make it to the root node. So that is 30 is here. 70 is here. This is lesser one similar to the previous one. This is in between these two. I will make the child pointer to this one. This is greater than that one. So I will point this one to this one. So likewise I will continue. Suppose I am going to insert in the left side. Suppose I am going to add some value. Suppose 5 I am going to add here. 5 I can add here and this will be like this. Clear? Next I am going to add some 15 here. How can I add 15? So 15 should be here. 3 is already there. I have to split. So what I will be doing is 5, 10 here. Okay. So what I can do? That is 20 is there. 20 I can make is there. And 15 I will put it here. So that's why it will become what? Look at this one. 15, 30, 70. Right? So what happens? 15 less than this one come here, greater than this one come here, that is 20 is here, okay, and the next 40 and 60, that is similar to the previous one. 40 and 60 will come here and 80 will be like this. Like this I can create. Suppose I want to add one more, so another root will be created. It will be added like this. Say one more example I will tell you. Suppose I want to add some 65. So 65 I can add 65. I can add 65 here. It is filled. Suppose I want to add 68. 68 I should add here. So it is already filled with 3. So I will split this one, that is 40, 60, and I am going to add 68, right? 68. This 65 come to the root part. So the root is already filled, right? So what I will be doing? So this root 65 I should add here. This root I will redo here. 15, 30 and 65 should be here and 70. So this 4 I will split. How can I split? That is, I will make 15, 30 and 17 another root and 65 I will make a root there. That is, I am splitting it into 2. Right? So likewise I can continue this process. So ultimately adding 65, the tree will be something like this. That is, it will have a 65 here. It is having a lesser value, that is, the node will be like this: 15, 30 as well as 70 will be there. From this 15 it will have 5 as well as 10. In between it will have 20. Next it will have 40 as well as what? 60. Okay, and one more node is there, that is known as 68. It will be coming from this one, greater than 70, that is 80 will be here. Likewise it will be arranged. Okay, so likewise this will be the final B tree. So this is what the peculiarity of a B tree. We can add it in one manner with following 4 rules. That is, in order to create a next node, half of the node should be full. At least a root node will have 2 children. That is, we are splitting when we can split it into 2, right? So root node will have minimum 2 children. All the leaf nodes will be in the same level always, and we are following a bottom up manner. That is, first we created this one, then we create the root, then we create the node. Likewise we are following. That's why it is known as bottom up manner. One more concept is there, that is known as B plus tree. In order to understand the difference between B tree and B plus tree, in B tree, from each node there will be a record pointer, right? This record pointer will point to that database. This record pointer will point to that particular database. 70's record pointer will point to that database. So 65, where it is present, it will point to that one. So that is what the peculiarity of B tree. So along with all the keys, there will be a record pointer which will point to that database. I hope it is clear. In B trees, the difference is that same tree I am considering, that is like 65, 15, 30, 70, next 5, 10, previous one itself I am taking, 20, 40, 60, 68, then 80 like this, right? It will not have the pointers, child pointers are like this one, this to this one, and this is to this is to this, greater than this one, this, lesser this one, greater than to this one. So these are child pointers. There will not be a record pointer from each key to the database. Instead of that one, we will create the duplicate of all the inside nodes, that is other than the leaf nodes, in the leaf nodes. I will repeat. I will create the duplicate of this copy of this key values to the leaf nodes. Other than all the leaf nodes, the values will be present in this one. That is 5, 10, 15 will be present here, 30 will be present here, 40, 60, 65 will be present here, 70 will be present here, like this. So all the key values will be present in the leaf node, and it will have a pointer from this one leaf node to another one. So how it look like? It look like a linked list. And from the linked list, leaf nodes itself, we will get all the key values which will point to that particular database. That is what the major difference between a B tree as well as a B plus tree. So in this class we have studied what is a binary search tree, and from that one we come to M-way search tree. M-way search tree, how can I use this for indexing? From that one, M-way search tree plus some rules. It is known as B tree. What are the rules? How to perform the insertion operation? Then what is B plus tree? What is the difference between B tree and B plus tree? That's all for today. Thank you so much.